All of you, and here is a beautiful problem on area bounded figure. Usually in recent trend it has been seen like J advanced is mainly focusing on area which requires two different kind of approach. One is integration, which fundamentally they can test in integration topic as well, which is connected with Leibniz rules. Second is they are trying to create area which does not require integration. For example, if you see the last 5 years problem, there was majority a problem which involved conic sections like basics parabola, ellipse or circle properties, okay, or trapezoid or rectangles where the calculation can be minimized. So one such beautiful problem is presented here. We have four set. I have given the same name for all these sets. It's better to give STUV. It's fine. So I'll solve the problem for 2024 and you can repeat the same problem for all the part till 24 to 27. This I've included in my upcoming book as well. So let's see how to solve the problem. The first is we have a set which is xy belongs to R2, means from 2D world, such that xy is positive and intersection of this curve. Now clearly second curve is a disk, circular disc, and the first is right. So you can clearly find the radius because if you'll make perfect square, it will become 2024. May how much will be added? Clearly you can see 5 will be added, so it will go to 2029 because the given expression can be written as x plus 1 whole square plus y plus 2 whole square is less than equal to 2029 because 5 is extra, so we have to find extra. So now I know the radius of this is root 2029, the circle. So the given circle is shown in diagram. अब इसके बाद let's see what we can do with this. Let's divide this circular region into some chunks, and by the symmetricity, since C is the center, so let's say the distance of this center point from x-axis is already, as we can see, it is -2. So if I draw a line, which is exactly having same distance below the center, so this will be y equal to -4, right? Let's draw another line. So its distance -1 from x-axis is 1. So if I'll draw another line, let's say x equals -2. So these four lines together with axis divides the entire circular region into 3, 3, 6 and 3, 9 region. So let's name this region as R1, R2, R3, R4, R5, R6, R7, R8 and R9. As you can clearly see, what I have done is I have divided this circle symmetrically about center. So let's say if I take two chords which is at the same distance from the center on either side, so this part will exactly be mirror image of this part. So both area will be same. Similarly, if I am taking two chords which are the same height or depth from the circle, so again this area will be same with this. So by symmetricity I can tell all these area chunks will be equal, okay, as shown in the diagram. So this fundamental properties of symmetricity I am going to use in this problem. Now according to our problem, we need to compute the area of this region R3 because in the first quadrant, and we have this area in the third quadrant, right? Since we already know R1 plus R2 till R9 is the area of entire circle, and that is nothing but radius is root 2029, so that will be 2029 pi square. In fact, it will be 2029 pi because pi r square will give that value, right? Well, so far so good. Now how to find the area of this sided region, right? Now we know since from symmetricity R1 is same as R3, so by symmetric argument is R1 is same as R3 area, writing equivalent, okay, and that is also same as R7. As you can see from this diagram, this corner is equal, so R7. My diagram is not up to the scale, so here the second small diagram is more appealing than the first one, right? So area wise these 4 is equal by symmetric argument. Similarly, you can see R2 is same as R8 because area of this chunk is same as lower chunk. And one more, R4 is same as R6. So we have R4 is same as R6. Right? So this gives the area of the required point, because area of required point I have to find is R3 union R4 union R5 union R7 union R8. Right? So what is this area? Now we know area of entire R1 till R9 is 29.5. Now if I'll put these informations like R1, R3 and R7, R9 equal to 8 and 4, 6 equal, what we are getting is R5 plus R7 plus R8 plus R3 plus R4 times 2, right, minus R5 is going to be 29 pi. And remember, the interesting thing is we need 3, 4, 5, 7, 8. So that's why we have 1, 3, 4, 5, 7, 8. So this part is required. So to calculate this part, just we need to know area of R5. Now very interestingly, what is area of R5? This region 5 is just a rectangle, right? This region 5 is just a rectangle. And by very construction we have seen the depth of this rectangle was 2 and 2. So it's 4. This length is 4. And we have this side length is 2. So that is going to give me 8 as the area of rectangle. So now the question is already done because this part is 8. So the total answer is 29 pi plus 8 divided by 2. Okay, so this is the answer for the first problem. Exactly in the same manner, you can repeat the process and you can find an answer for all these following steps. I hope you must have enjoyed the problem, and the point was how smartly we have introduced the line of symmetricity in the question and we have avoided any integration as such. You can give another symmetricity argument and that is left an exercise for you. Please, if you are getting any such ideas more simpler than this, write it in the comment section. Yes, integration can also be one, that will be very difficult because you have to integrate this portion plus again this area and you have to integrate this portion, or maybe out of this entire portion you have to throw away some portions. Okay, so that will become more crazy.